Okay, great. Hi, everyone. I'm Mady Mantha. I'm the Artificial Intelligence Platform Leader at Sirius, where I own the strategy and vision for AI and machine learning. I'm also a machine learning architect, so I build and design machine learning applications, and we're really passionate about building artificial intelligence solutions that work for everyone. We're augmenting processes with scalable machine learning so human systems can delegate the mundane and focus on innovation. So today I'm really excited to be here and talk to you all about something that I really love working on, and that's NLP. So before we began, I should also mention that a person on my engineering team was supposed to be here today, but she couldn't make it, so I'll try to cover some of the things that she wanted to talk about. So I want to start by doing a quick overview of NLP, which I'm sure we're all very familiar with, and then we'll dive right into the problem space, where we were implementing a contextual assistant and we had some issues implementing it with issues with entity disambiguation and so forth, and we solved some of that using BERT. So I want to talk to you a little bit about what that Rasa BERT integration looks like. We'll also take a look at how this model outperforms some of the other models that we looked at, and how that fits into our overall implementation. And then we'll just take it from there, next steps, any questions you guys may have. Also, I want to say that when we talk about performance, I'm going to be talking about accuracy here, not generality or scalability, which are also very important, but for the purpose of this conversation, let's focus on accuracy. So, NLP is not a new concept by any means. Linear regression has been around for centuries now. Conversational AI has been around since the 60s. But we've been experiencing, conversational AI and machine learning have been experiencing a renewed focus in recent years. And I think that's because we're at a seminal moment in computing. If you take a step back and think about it, computing, the history of computing has always had major shifts every 10, 15 years or so. It started, with the personal computer in the 80s. It really changed the way that we interact with technology. Then, oh my God, look at that. And then about 10 or 15 years later, you had the internet, which the internet is arguably one of the biggest shifts in our lifetimes, right? It democratized technology. It changed the way that we do business. It revolutionized industries. And then about 10 or so years later, you got the smartphone. Now, the smartphone led and continues to lead a radical shift in the way that we interact with technology and in the way that we interact with one another. But we're at another moment now where we're moving from this mobile first to an AI first world. And what do we mean when we say AI first? I think it means that we're talking about technology that you can naturally converse with. I think it means that we're talking about technology that is thoughtfully contextual, that learns and remembers context. It doesn't have to be reminded of it each time. It delivers a personalized experience for you. And I think it means that we're talking about technology that learns and evolves and gets better. It becomes more intelligent with each iteration. At the heart of all of this is NLP. Now, NLP is something that you use, obviously, when you're building a performance search engine, to autocomplete, to spell check, to auto-classifying documents, invoices, stuff like that, processing them, and of course, conversational AI. So NLP, conversational dialogue systems, et cetera, is the most complex, really intriguing, and exciting things to work on. And I think that's why it naturally fascinates data scientists and machine learning engineers. So here's our problem space. We wanted to build a contextual assistant that augmented the help desk and IT team's capabilities with conversational AI. So we wanted to build an assistant that could answer questions that the help desk team routinely deals with. So stuff like, how do I open a ticket? My Outlook isn't working. Can you help me with that? How do I download Zoom? Things like that. And then we wanted the bot to be able to walk you through how to resolve some of these routine technical IT issues that you face. So, hey, my Outlook's not working. Can you fix that for me? Or can you walk me through that process? And stuff like that. So in addition to just answering questions, which is something that any rule-based bot can do, we wanted to go a step beyond that and really be able to, in addition, it's fine if you have a bot that can answer questions, But when you have a contextual assistant that can perform tasks for you, do things for you on your behalf, that's when you start to add true value to any engagement. So we focused on purposeful automation. We integrated with third-party services like ServiceNow, and Workfront and Outlook and things like that, so it could actually do things like opening a ticket on your behalf, escalating it up the escalation path, notifying stakeholders, and things like that. So you can focus on innovation. The chatbot does the mundane stuff. And then we wanted to take it a level above that, where the bot could offer personalized, intelligent recommendations for you. So we got the bot, and we're currently working on this. We got the bot to do things like, hey, it looks like 80% of your colleagues have upgraded to Microsoft Office this weekend. They faced a lot fewer latency issues. Do you want me to upgrade for you? So surfacing the right information at the right time in the right channel has been our goal, and I think that's what Rasa means when they say they're building, they can help you build level 3, level 4 contextual assistance, and that's what we were able to do. So while we did a lot of user research, user testing, training, retraining, because you really want to be able to user test your contextual assistant as much as possible, as often as possible, and really do it as quick as possible. Don't wait until your bot's perfect. Just get it out there and start testing it. So we tried to do that, but we started seeing some issues with entity disambiguation. So let's say you're building a travel bot, and you want to say something like, I want to book a flight to San Francisco, or I want to book a flight to Chicago, and you don't necessarily specify both the source and destination entities, that could be problematic for traditional neural networks. Or let's say you're saying something like, I'm on my cell. That can be problematic for traditional neural networks because they're stateless. They don't really have a memory effect or specific memory cells. So humans, we can automatically catch that because our thoughts have persistence. We understand context. So when you say I'm on my cell, I know that you probably mean you're on your cell phone and not like a biological cell or something like that. So while traditional neural networks can't really deal with this, recurrent neural networks, LSTMs, attention models, transformers are really equipped to deal with memory and persistence because their networks have loops in them. So those loops allow information to persist. And one of the biggest problems I think today we're solving with NLP is not really with accuracy, because a lot of models right now are accurate, but it's this problem of generality, which is why a lot of really talented people are focusing their efforts on transfer learning, multitask learning, Bayesian program synthesis, and things like that. So we can really try to get closer to that generality aspect. So we looked at all of these models, CRFs, LSTMs, encoder, decoder models, and we really zeroed in on BERT, because last year, around this time, it was state of the art. And a lot of people were seeing some promising results with it. So we thought, all right, why not? Let's use BERT. And BERT, for those of, I'm sure we're all familiar with it, it's a pre-training NLP technique released by Google. One of the cool things about BERT is that it has the ability to pre-train bidirectional, contextual language representations modeled on like a large corpus of text. And as a result, the pre-trained BERT model can be fine-tuned with just one additional output layer. You don't need multiple. And using that, you can really create state-of-the-art models for downstream NLP tasks, for named entity recognition, question answering, language inference, and things like that. And we specifically used it for NER and autosuggest. So I want to show you a little bit about how we integrated with BERT. As you know, Rasa NLU is a pipeline that has one or more components. Oh, excuse me. OK, so let me play this video here for you. I'm not doing a live demo because I don't know if you know this. It's a rule that live demos don't work. So OK, so this is the Rasa pipeline, and it includes a pre-trained embedding spacey, as the name suggests. It uses pre-trained word vectors from GloVe and FastX. You also have a TensorFlow embedding pipeline that doesn't use pre-trained word vectors, but instead it learns embeddings from both intents and words simultaneously. And you can also take advantage of entity extraction components like duckling, CRF. We use duckling and the synonym mapper. So you can cherry pick any or all of these components to really create your NLU pipeline. And we've customized it with BERT. As you can see from the NLU config file, we added the BERT component to the pipeline. So based on the component's name, Rasa is going to invoke the corresponding Python class. So since BERT is the first component here, BERT NER is invoked first, followed by the other components like the TensorFlow embedding pipeline and so forth. So I want to point out that the custom BERT component that was added to the NLU pipeline was a wrapper to the BERT service. And so the service was then fine-tuned to load the model to memory to speed up the request processing. And I know that the folks at Rasa have tried to implement BERT with their pipeline, but they saw some latency issues. So it's performant in the sense that it's very accurate, but it doesn't really allow you to scale because it's slow. And you see latency issues, and you see maybe like a 5-second latency issue, which is really unacceptable when you're talking about conversational AI. But we were able to find a workaround to get around some of these request processing issues and speeding it up. OK, now let's take a look at how it compares with other NER models. So we'll take a look at a quick comparison with NER CRF and spacey. Now, I want to be clear, they're both awesome models. And actually, like we talked about, BERT is slower. And we were only able to get around the latency because we fine-tuned the service to load the model to memory to speed some of that stuff up. So that's the major drawback with this BERT integration. But looking at several examples for all of our use cases in 4 different assistants doing things from IT to HR to password resets and stuff like that and travel desk, we were really able to find that BERT outperformed some of the other models that we looked at. So let's take a look at how it compares with spacey and Stanford NER. And I think for this example, we'll take a look at BERT with a travel assistant. So we're going to start off with BERT. It's going to, we're going to try to book a ticket. And then I didn't really specify the source, the destination, the source entity. But it was able to tag it and extract it accurately. So we tried to compress some of this to make it a consumable video, but the code is available on GitHub. So feel free to check it out. So now we'll do NER CRF. And again, it's the same travel assistant example. So we're going to try to book a flight. And we'll say we're booking it to the destination. So a lot quicker here. So as you can see, wasn't really able to identify and extract that. And now we'll take a quick look at spacey. again, I want to say, this is something that worked for us. I'm always mindful of making these comparisons in, 20 or 30 seconds. It may not be a complete comparison, and there's lots of variables at play, but in our particular use case, we found that it works better, and so we stuck with BERT for NER and auto-suggest. Again, as you can see, that's spacey. All right, so now, just for fun, let's see how this compares with certain other out-of-the-box NLU services like Microsoft's LUIS. So if you're familiar with the Microsoft Bot Framework, you use LUIS for NLP, which is a performant service. We'll also take a look at how it compares with Google's Dialogflow, which is also good. Again, this is not a complete comparison at all because BERT obviously is a language model, and Rasa BERT is our custom NLP pipeline, which we're seeing good results with. But if you wanted to compare it with other NLU services, you could for fun. So we tried doing this because we were playing around with it, but I thought, I wanted to show it to you guys. So obviously, if you say, book a flight from Chicago to San Francisco, it's going to work for sure. But let's do what we did before when we didn't specify the source entity. You just say, book me a ticket to destination. It has some trouble. And you can use, I think, some of the out-of-the-box system entities that LUIS provides. We tried doing that, but it wasn't on par. Same thing with Dialogflow, wasn't able to do it. And now with BERT, as you can see, a little bit slow, but it will get there. And that should give us what we're expecting. Can you imagine if this were a live demo? I'd be sweating up here, hoping that it worked. Okay, so I want to show you the end result here for when we built just a sample travel assistant, contextual assistant, just for fun. We're using it internally for research purposes. So this is what it looks like. And you want to be making continuous improvements to your conversational AI because it's vital. I mean, obviously, it's going to make mistakes. So you want to make continual improvements to it. You want to train it. You want to fix certain mistakes and push the trained model back into production. So, human language is messy, right? There's 40,000 different ways you can ask about the weather. One of my favorite ways is when people say, is it going to be raining cats and dogs today? So how do you account for such complexity and being able to identify and really, handle some of that? Now, as you can see, our Rasa BERT pipeline, and Rasa gives you ways to handle, when users issue corrections, handle chit chat and stuff like that. So here, the bot's trying to book a vacation for this person. So they say, yeah, it's just me that's going. And in order to do that, it's going to ask you a few questions. They say, it's just me that's going. And then they change their mind, as users typically do. So when you're thinking about a call center or something like that, a user may say, yeah, open a ticket for me. And then they may say, scratch that. I actually don't want to update my ticket. Or, no, sorry, that was my wrong account number. This is my right one. So you want to be able to handle corrections like this assistant was able to do. And then they will engage by switching context, right? So if you're trying to ask another question, they'll say, well, why do you need to know my account information? Why do you need to know where I'm going? And so the bot should be able to provide an answer and then nudge the user back onto the happy path so it can do what it needs to do to get the job done. All right, and now, we even played around with NLG a little bit, and it's still something that's kind of new and not operationalized or productized at scale, but I think it will be. So I'm sure you're all familiar with OpenAI's GPT-2 language model, so I tweaked that, and I used it just for chit chat. because with NLG, like we were talking about with generality, we're not there yet. So we wanted to use NLG just for a chit-chat, small talk scenario. So again, who's going? You're going to give an answer. And then if the user were to just engage in chit-chat. So it answered that. Would you say that that's neutral, right? Not entailment, not a contradiction. I feel like that would be neutral because, we were asked, what music are you into? It said, I am into music. I mean, it's okay. I mean, it's not bad. So it's fun to play around with this. NLG is a very new and exciting space, and there's a lot of really cool research being done here. And I think, once it's operationalized to use at scale, I think that's going to be something super exciting. So we know that when you're building conversational AI, there's lots of things that you want to think about. Obviously, NLP is a huge part of it, but there's also purposeful data-driven automation, automate things that users actually want to use, have intuitive conversation and stuff like that. So, we've been working on this, and it's been a really exciting time. I want to continue working on it. I really learned a lot from you guys today, and I look forward to keep learning, and let's be on this journey together. Thank you.